So looking at solving these functions, solving the equation for x. So if I want to know what x is and I'm given these two functions, I want to set the functions equal to each other and then solve for x. So I'll set f of x equal to g of x. So let's write it out like this. F of x equal to g of x. But now I can say, well, what is f of x? Well, f of x is this 15 minus 3x. And that'll be equal to g of x. And g of x is 10 minus 4x. Now I want to solve for x. What can I do here to solve for x? What can I do to solve this problem? -5, very good. So we can combine our like terms and our x's. We can combine our constants, our numbers to one side, and then we just isolate the x. So our solution is x equals -5. That is our solution. Okay. Cool. Let's do one more algebraically, one by table, and then we'll look at some problems very similar to your examples today. All right, here we go. Let's do this one. This is example 2 if you want. This we can say is, how about we do 92 plus 4x. So f of x is equal to 92 plus 4x. And g of x will be equal to 83 minus 2x. If I want to solve this algebraically, what do I need to do? So we say f of x is equal to g of x, but what is f of x? (92 plus 4x). Good. And somebody other than Lacey now, what takes the place of g of x? Nice job. There we go. 83 minus 2x. So now we're just solving this equation again. And I think we can do that. I want to combine my like terms like Antonio was saying last time. How do I combine them here? Beautiful. Yeah, let's add 2x. I like that we are adding 2x here. That's a good step. And I'm going to add the 2x not to the 92, but to the 4x because those are my like terms. So we'll add 2x there. What's 4x plus 2x? (92). Good. And then 4x plus 2x is 6x. Thank you, Chase. 6x. Good. And then I'm just left with this 83 over here because these 2x's minus 2x and plus 2x cancel out. Great. Now I want to get these 6x by itself, so I need to get this away. How do I get rid of this 92? There we go. Good. I'm going to subtract 92. Cool. So these 92's go away, and I'm left with 6x is equal to, what is 83 minus 92? Nice job. Yeah, -9. All right, and let's see who's got this. Um, Rachel, can you help me out with this one? Rachel, how do I get rid of this 6 here? This says 6 times x. How do I get rid of that 6? So we divide by 6 on both sides. The 6's cancel out here. And I get x is equal to -9/6. But I think I can reduce that. -9/6. That's a fraction. It looks like they're both divisible. What goes both into 9 and 6? Okay, good. I could simplify it to a decimal. I like that we're going to use a decimal. Let's take a stop here though and do a fraction real quick. Good. 3 goes into both 6 and 9. So I can divide both the top by 3 and the bottom by 3. And if I do that, -9 divided by 3 is what? 3, but it's a -9, so it's a -3. And then 6 divided by 3, well, that one's easy. I can do that. That's 2. And then maybe this makes it a little bit more clear, like our decimal answer suggested. 3/2, that's one that we should know. And that'll be -1.5. So our solution, again, solution, ooh, can't write and you can't see. Our solution is x equals -1.5. Now, one of the reasons that algebraically solving these is nice is because we probably wouldn't guess a decimal answer to solve it as a table. So we're going to solve the next one with a table. But when we do this, we probably won't get a decimal answer. So algebraically is nice because we can get a decimal number and it's just fine for us. Some of this table stuff then real quick. It's in your notes before, but let's break it down step by step. Let's say step 1 here. Step 1, we want to pick values for x. Okay. We're going to pick values for x in our table. So we're creating a table of values. Step 2 here will be to plug all of those x values in to both functions. So plug the x values in to both functions. And step 3 here, identify the row where the functions have the same value. 3 steps, but remember tables can take a little bit longer depending on our guesses. So let's look at a quick example here. Let's see if we can guess pretty well. Let's say that I've got f of x here is 55 plus 25x. And g of x is equal to 100 plus 10x. We'll build a table. So let's get a table going. We don't know how many rows it needs to be yet. It depends on how many guesses it takes us. I know I need 3 columns. 1, 2, and 3. This first one will be my x. These will be the x values that we pick. The second column is our f of x, the values of the function, and then g of x. What's always a pretty good number to pick? What's a really easy number to pick for x? Okay, 5 is a good one. I see lots of 5s in there. So 5 would make sense to pick. I think that's an excellent one. We can pick 5 for sure. Let's add 5 to our list. We'll put 5 down here. Maybe we want 5 in towards the bottom of our list. What's a really easy one to start with though? Yeah, good. 0 is always a good one to pick to start. 0 is kind of a special number. So if we can pick 0, I think that'd be very good. Let's do f of 0 together, and then we'll see if you guys can come up with g of 0. So if I take f and I want to plug in 0 for x, so this will be 55 plus 25. Okay, but I'm plugging in 0 for x. So this is 0, and this is 25 times 0. What's 25 times 0, Chase Summer? 25 times 0. Good, it's just 0. So this becomes 55 plus 0. And what's 55 plus 0j? See if J's still there with us. 55 plus 0j. There you go. Good job, Jay. You're there with us. So 55. So 55 goes in our spot here. If we wanted g of 0 now, let's give you a minute and try g of 0 on your own. So we can set this up for you. But I want g of 0. That'll be 100 plus 10 and 0. What do we get for g of 0 here, guys? Let's see who comes up with this. So now we're looking at f of 5 and g of 5. So we plug in 5 for our x. Antonio says he's got this one already. Nice job. This one's and solid. Good. 150. And let's see if we get that other one too. So we thought 5 quarters, 5 times 25 is 125. And 125 plus 55. There you go. Good guess, Haley, but yeah, remember it's 55. Okay, so we add that 5 in there. That's 180. Okay, good. So again, they still aren't the same. So we're looking for where they're the same. Notice f of x is lower than g of x here, but then it's bigger than g of x here. So we know it's got to be somewhere in between 0 and 5. So I don't need to go any lower than 5. What's a good number that I could pick next? What's a good guess between 0 and 5? 2? Let's try 2. We plug in 2 here. All right. Let's have f of 2, 55 plus 25 times 2. And then we also want g of 2. 100 plus 10 times 2. Let's see. Haley and Rachel, can you help me out with these two? So they were pretty far apart. Then we moved to 2 and they got closer, but F is still lower than G. So now I want to be between 2 and 5. What's a good number to test between 2 and 5? So again, we found that the f of x and g of x had the same value at x equals 3. So our solution is x equals 3. All right, we have one last strategy to check, and then we're going to do part of your homework together here. So let's take a look at our one last strategy. I know this is a lot, but you guys are doing a great job today. Absolutely on it. And the last way that we can solve these equations using functions, the third way that we're going to talk about, is we can do it graphically. And when we think about the word graphically, we see the word graph. So what we're going to use in this case is a graph. And this is a two-step situation here. We can say step 1. If we're going to use a graph, the first thing that we should do is graph both functions. Graph both functions. Once we've graphed them, and we'll review how to graph some functions here in a second, but once we've graphed them, all we need to do is find the intersection. What is an intersection? What does the word intersection mean? We could say when they cross. Okay, so this is just when they cross. When they cross, as in what number did we plug in to have the same value? Okay, so let's take a look at graphing these. And before we graph them, let's remind ourselves how to graph them. If I give you this as an example, let's say that I say f of x is negative 1/2 x plus 2. I want to know what form this equation is. This is a linear equation because it doesn't break my rules, but what form is this in? Standard, point slope, slope intercept. Good, so this is in slope intercept form. What is our slope here? Negative 1/2. Good, so our slope is negative 1/2. And slope is, it's always, this is our kind of call and response here. Slope is rise over run. Good. Slope is our rise over run. So we'll use the slope to help graph. What's our y-intercept? Our slope intercept here. Good. 2. So we'd start by graphing our y-intercept and then using our slope to find another point. So that's our first equation. Let's look at g of x here. If I tell you that g of x is negative 3x minus 3, what is our slope in this case? And what would our y-intercept be? So we write our slope as a fraction, negative 3 over 1. That'll help us graph it. Then our y-intercept is actually the same thing. Yeah, it's just negative 3, but we don't need to write that as a fraction. Cool. So what we've done is we've decided that this is the important information from these two functions. Now, I'm not going to ask us to graph these in our notes because I've already got the graph drawn up here. But let's just look at the graph to see if we can answer the question to solve this function. So if we were going to graph those two functions, my y-intercept for f was 2. And then I had a slope of negative 1/2. So I went down 1 over 2. Or I went up 1 back 2. And that gave me a line. I need 2 points to create a line. And then I could graph the other line as well, which had a y-intercept of negative 3 and a slope of negative 3, which means I went up 3, back 1. And if I keep going, I went up 3, back 1 again. To solve this equation, to solve these equations, I want to know what is the x value where they intersect. What is the x value where they intersect? Well, I find the intersection, that's right here. And my x value is the horizontal. So my solution to this is x equals negative 2. So what we can say here is that the solution, we pop back into our notes just so we've got the answer here. We can say the lines intersect when x equals negative 2. So that's all we're going to say for solving with graphs. All right.